Hello, this is Britt Caswell with another example video. In today's video I'm covering example 5 from section 3-4 in the SavvasRealize Algebra 2 textbook. So in this example we are looking at how to tell whether a binomial is a factor of a polynomial. And so I have the option of either using the remainder theorem, which is where I plug the value into the function, or what's called the factor theorem. Now the factor theorem is where you do the division and you look at your remainder, and if your remainder is 0, then it is a factor. Alright? So they want us to figure out if this binomial x minus 6 is a factor of this polynomial. So just remember, a factor means that it divides in evenly without a remainder. So for example, if I do 30 divided by 5, right, that would equal 6, and then when I subtract I have a remainder of 0. So that remainder of 0 tells you that 5 and 6 are both factors of 30. Alright, in this case I'm going to do synthetic division just because I like it more than plugging into the polynomial. So I'm going to take my binomial in question and set it equal to 0. So I'm going to put a 6 outside of my synthetic division house. And so now I'm going to write out my coefficients. So I have 1, negative 8, 16, negative 23, and negative 6. And then I do my braid. Oops, it's a 1, not a 6. Don't make any goofs, guys. So 6 times 1 is 6, and then I add down. 6 times negative 2 is negative 12, and then I add down. 6 times 4 is 24, and then 6 times 1 is 6, and when I add down I get a remainder of 0. So the fact that this remainder is 0 tells you that x minus 6 is a factor. And so then it says write the polynomial in factored form. Now this is a different form than you've seen, so make sure that you guys are watching it kind of closely. So when it's written in factored form, I take my first factor, which is my x minus 6, and then I'm going to put it as being multiplied by the results from my polynomial. So I need to write this out as a polynomial. So my original polynomial was to the 4th, so this will be to the 3rd. And that's what's going to go down here. Alright, so there is our factored form. Now if there was a remainder, I would just add whatever that remainder is right there, whatever number it is. Alright, so let's go ahead and let's try this next one. So my binomial is x plus 3, so I set that equal to 0. And that's what's going to go outside my synthetic division house. Now remember, when I set up my synthetic division here, I need to make sure that I plug in a 0 for the x to the 4th power, because you can't have any holes in there. My cat Kyoza is so excited about the remainder theorem, y'all. If y'all can hear her in the background, she's having a ball with it. Alright, so there's all of our coefficients. This one's kind of a long boy. Alright, so I drop down my first one. Negative 3 times 1 is negative 3. Negative 3 times negative 3 is a positive 9. I get a negative 12 by multiplying, and then I add down. Multiply again and get a 9, which puts an 8 here. When I multiply, that's a negative 24, which gives me a negative 21. So this is not a factor. So because the remainder is not 0, x plus 3 is not a factor of the polynomial. Okay? let's go ahead and let's check this out. So these ones are asking us just if it's a factor, not necessarily asking us to write it in factored form. Let's change colors, get a little more exciting with the purple. So x minus 4, I set it equal to 0. And so that 4 is what's going to go outside of my division house. So then I drop down my 1 and do my braid. So I add down, oops, there we go, multiply again, and then I add down and get my remainder of 0. So x minus 4 is a factor. And again, that's because of a remainder of 0. And I think we just have one more. Yeah, so here's our last one. So I take the x plus 5 and set it equal to 0. Alright, so that negative 5 goes outside of my synthetic division. And so now I'm going to go ahead and write in my coefficients. Make sure, guys, that you mind your signs, by the way. Don't make any goofs there. So now I do my braid, so negative 5 times 2 is negative 10. I multiply again, I get a positive 5. Multiply again, get negative 15. Multiply again, I get a positive 40, which when I add down gives me a remainder of 0. So that remainder of 0 tells us that x plus 5 is a factor of the polynomial. So there you all have it. That's how we test to see if a binomial is a factor. Until next time.